Welcome, everyone. So glad you're here for today's explainer. Today, we're unpacking a piece of research that, honestly, represents a massive paradigm shift in how artificial intelligence interacts with the internet. We're looking at a system called Webwright, and it completely reimagines the whole relationship between an AI agent, your web browser, and the tasks you actually need done. If you've ever sat there watching an AI just completely struggle to navigate a complex website, you are definitely going to want to pay close attention to this. I mean, just imagine this for a second. Imagine an AI that doesn't just act like a human clumsily clicking a mouse or endlessly scrolling down a page. What if, instead, it operated like a highly skilled software developer writing a custom script just for you? So instead of just handing you an answer and calling it a day, it actually gives you a reusable program. That right there is the core premise of Webwright. All right, let's jump right into Section 1, the web agent problem, and why our current AI tends to break. To really get why this new approach is such a big deal, we have to understand exactly why our current AI web assistants break down so often on complex tasks. You see, traditional web agents are incredibly fragile. They basically keep one single browser session alive and try to guess the very next primitive action, like a single click, a keystroke, or a scroll. They are completely trapped in a single stateful page. If that page reloads unexpectedly, boom, the agent breaks. But Webwright takes a totally different approach. It completely separates the agent from the browser session. These Webwright agents operate directly from a terminal. They can spin up a browser, take a look around, and then instantly throw it away without ever losing their place. Which brings us to Section 2, the terminal native shift, focusing on code over clicks. So giving an AI a terminal environment, it's a total game changer, really for three core reasons. First, because the AI is living in a terminal, it relies on actual code rather than primitive, clumsy clicks. So things that usually trip up AI, like selecting dates, filling out long forms, or extracting data, suddenly become clean, efficient code loops. Second, the AI can spawn these fresh, disposable browser sessions just to test the waters. If an attempt fails, no big deal. It just inspects the failure, closes the window, and tries again. And third, crucially, it leaves behind durable artifacts. We're talking exploratory scripts, action logs, screenshots. All of that survives safely in a local workspace even after the browser is closed. Let's look at Section 3, the minimal harness loop, which is remarkably built on roughly 1,000 lines of code. Now, hearing all this, AI agents writing code, managing terminal windows, saving logs, you'd probably expect there to be this massive bloated software architecture running the whole show behind the scenes. Well, you'd actually be wrong. The entire system is built on a remarkably minimal harness. We're talking roughly just 1,000 lines of code. So that begs the question, how on earth do you orchestrate all of this without massive complexity or some crazy multi-agent planning hierarchy? The secret is in this incredibly elegant, continuous four-step loop. Step 1, the runner sends the context to the model. That includes the task, the current state of the workspace, and any recent observations. Step 2, the model emits bash. Basically, it returns a block of thinking and a shell command, often writing little scripts to explore web pages. Step 3, the environment runs that exact command and hands back the terminal output, the logs, or even error tracebacks if something went wrong. And finally, Step 4, refine and finish. This loop just keeps spinning, repeating these steps over and over until the task is absolutely nailed. And this is where it gets really clever. Webwright has a brilliant way of preventing those frustrating open-ended AI failures we've all experienced. They built in something called the premature done gate. Basically, before the system ever accepts a task as officially done, the agent is forced to generate a final script, run that exact script in a totally fresh, empty folder, save the output logs, and then pass its own self-reflection judgment. Literally, it forces the AI to double-check its own homework from scratch before declaring victory. All right, Section 4, building reusable AI skills. Let's look at a flight comparison task. Because theory is great, right? But to really grasp how powerful this is, we need to see it in action with a real-world application. Let's look at booking a budget flight from Hong Kong to Jeju Island. If we trace the AI's thought process chronologically, at 0 minutes, the task kicks off with a budget of 20,000 Hong Kong dollars. By minute 143, the AI has already written the code to open Google Flights. At the 3:20 mark, it spots the absolute cheapest nonstop flight at 2:30 a.m. Now, a basic AI would just stop there, book the ticket, and be done with it. But check this out. At minute 408, Webwright starts evaluating a more balanced option. It identifies a much more practical 8:35 a.m. flight, and by minute 556, it actually recommends that morning option because it has the logic to realize that saving a few bucks is absolutely not worth the pain of a 2:30 a.m. departure. I mean, that is sophisticated, human-like judgment right there. Now, navigating a complex booking site takes a lot of time, and Webwright handles these long horizon challenges beautifully. It uses something called context compaction. That means it periodically summarizes its own past actions so it doesn't run out of memory during a long coding session. But here is the true magic of the system. Once the AI actually solves this complex flight comparison, it doesn't just forget it. No, it exports the entire successful workflow as a parameterized, reusable command line tool. It literally turns the solution into a shareable skill that you can run again anytime. Which leads us to Section 5, the performance leap on the hardest live benchmarks. So, the big question, does this terminal native approach actually translate to better real-world performance? Well, on the Odysseys benchmark, which is designed specifically to test long-horizon browsing capabilities, Webwright achieves a massive 60.8% score. Just to put that into perspective for you, that represents a 35.1% relative improvement over the previous state-of-the-art models. That is a huge leap forward. And it gets better. When the researchers tested the model on the online mind-to-web benchmark, it yielded an incredible 86.7% accuracy. And keep in mind, this wasn't tested in some perfectly controlled, sanitized lab environment. No, this was tested across 300 live, unpredictable tasks on 136 different real-world websites, all while operating under a really strict 100-step budget constraint. But honestly, this might be the most impressive part. You don't even need a massive, super expensive frontier model to see these gains. Even smaller, more accessible models see huge benefits. When a smaller model like Qwen 3.59b is augmented with these reusable tools that Webwright generates, it manages to hit a 66.2% accuracy rate on the absolute hardest splits of the benchmark. Essentially, these tools let smaller models punch way above their weight class. To really sum up the core philosophy of this research, the authors put it perfectly. They state, the output is not just a completed task, but a reusable program. Webwright isn't just a basic assistant doing a chore for you. It learns how to do the chore, it completely perfects the process, and then it hands you a custom program so that specific chore is automated for you forever. So, as we wrap up today's explainer, I really want you to think about this. We're officially moving away from AI as a mere clicker of buttons and moving toward AI as a master builder of bespoke tools. If your AI could build the exact reusable programs you need, perfectly tailored to solve your unique problems forever, how is that going to change your daily workflow? Think about it. Thanks so much for joining me today, and as always, keep learning.